All right, Algebra 2, Unit 6, Lesson 15 is called Features of Trigonometric Graphs, Part 1. All right, before we go into the warm-up, I want to make sure we understand how to graph a basic sine curve and cosine curve. So y equals cosine theta is right here in blue. Y equals sine theta is in red. We should know that. That was a few lessons ago. Both of them have a period length of 2 pi. So when I say period length, we're talking this distance from here to here. That length is 2 pi, whether you're on the sine graph or the cosine graph. They both have an amplitude of 1. Amplitude is from the middle or the midline up to the top, or the midline to the bottom. Okay. Slightly off there on my graph, but that distance right here is 1. That's my amplitude. And they also have a midline of y equals 0. So my midline is right here, y equals 0. So we learned, if I start doing things to my function, if I put let's say I put a 2 in front of here. Let's say I do y equals 2 cosine theta. The number in front changes the amplitude. So I'm going to go up here to 2, down here to negative 2, and go like that. My amplitude gets bigger. If I put let's do a -1. My graph's going to shift down 1, so everything moves down 1. So my midline now goes through here, right through the middle of my graph, but it's now at y equals -1. The other thing we learned is if we have y equals sine of theta minus pi over 2. If I minus something, it's going to be a horizontal shift to the right. So every point is going to move to the right pi over 2. So it would be a horizontal translation to the right pi over 2. If it was plus pi over 2, like that, it would move left pi over 2. So every point, like this point, shifts left pi over 2. Oops. This point was originally there, shifts left. Everything moves left pi over 2 if you have something like that. So we've done, basically, we know midline. If I were to say y equals a times sine of b theta minus c plus d, we've learned a here determines amplitude. D determines midline. C determines horizontal shift. We haven't done anything with this value for our period length. Up until now, my period length has always been 2 pi. So today we're going to learn a little bit about period length. So here's the warm-up. What do you notice? What do you wonder? Take a minute, look at the video, or look at the picture, and if you need to pause it to write down some things, go ahead. I'm going to jump right into it. So some things that I might notice. Curve A has greater amplitude. Curve B has 1 period. curve A has 2.5 periods. Okay. And if you need to see this, here's 1 period, there's 2 periods, and there's a half. Versus curve B does 1 full period. Okay. All right. What else do I notice? I noticed that they both look like sine curves. All right, let's do some wonders. I wonder what are the numbers on the axes. I wonder if A is horizontally compressed or if B is horizontally stretched. Okay, because like I don't know where 2 pi is. So if this is 2 pi here, curve B is our parent function, and curve A is horizontally compressed to get it having more periods. Now, if 2 pi is here, right there, curve B is horizontally stretched. So we don't really know which way it is. What else? How about this? I wonder if, or could either of these be cosine curves that are translated? Okay, so for example, if this is 1 here and this is -1, -1, and this is 2 pi. Let's just say this is 2 pi. So could I write this, if this is pi over 2 here, could I write this as y equals the cosine of, now I have to use x because it says x on the x-axis. If you look right here, it says x. So x minus pi over 2. That would actually be the same as y equals sine of x. Those would be the same exact graph. So I wonder if I could write it with a cosine. Lots of stuff there that we could talk about. Good discussions being opened up on that warm up. All right, so here we go. Let's match each equation with its graph. So as I look at one, and you should try to do these on your own. Pause the video, try to do these. If you need to verify your work with graphing calculator, I would open up Desmos and take a look at them. I'm going to just kind of fire through them real quick. So the first one, y equals negative cosine theta. So this is going to be d. Why? Because cosine theta looks like this. And it's going to be flipped. Everything gets reflected across the x-axis, and that would give us that graph right there. Okay. So there we go. Number 2. I look here, I got an amplitude of 2, and then I have a midline of -3. So I'm going to take a look at my graphs here, and I'm going to go right to -3, and I look right there. That looks like a midline of -3. This one here is not, and these graphs don't even go to -3. They're like way off, so obviously not those two. A looks like it's midline. B does not look like a midline, so I could probably say it's A already. You could also take a look at your amplitude here. My amplitude is 2 from here to here. That is 2. So is that. So this is definitely A. Let's go to 3. 3 is a cosine graph, but I'm translated left pi over 2. So let me clear these up. So cosine, so my midline's at 0, so I could get rid of A and B. It's definitely got to be C or D. So my midline, so let's do this. Let's just graph the cosine graph. Let's just translate everything left. No, yeah, left pi over 2. And move everything left pi over 2. And again, my graph is not perfect here, but this looks pretty good for C. All right. Go to 4, amplitude is 3, midline is -2. Okay, there's my amplitude and midline. So I'm going to go midline -2. I look at this one here, and then I look at my amplitude. That distance from midline right there, that is 3. So looks like 4 is going to be B. And then we go to 5. So 5 is a sine curve, but it's translated right pi over 2. So here's what I'm going to do. I'm going to graph my sine curve. So that looks like that. And I'm just going to move right pi over 2. So I probably need to follow the pattern. It would go like that. That looks more like D. And then the last one, same graph. It's a sine, but I'm going to go left pi units. So I'm going to put my finger right here on this point right there, and I'm going to move I'm going to move every point left pi. So that looks like C. Matches up right there with that. Okay, and you can graph them on Desmos and check your work, or you can kind of just should know enough to be able to do those. That's all review. Nothing new in that activity. All right, next thing, complete the table of values for the expression. So sine of 2 pi. So here's my angles. I'll tell you what, I'm going to eliminate these two right here just to make it easier. So sine of 2 times 0. Well, that's the sine of 0. You should know on the unit circle the sine of 0 is 0. And this is just my scratch work here. Sine of 2 times pi over 4. So 2 times pi over 4 is pi over 2. And the sine of pi over 2. Again, you don't need a calculator. Sine of pi over 2 is, this is 0, this is 1. So right there. I'm going to kind of just go through everything and fill in the table. Again, you got to take each one of these values here and you got to times them by 2. 2 times your theta, okay? And then you have to take the sine of that value, okay? So I'm just going to kind of go through it here. This is 0. This is -1. Sine of 2 pi is 0. This will end up being 5 pi over 2. So 5 pi over 2, and a lot of people forget this. That is on your unit circle. It is, I got to go pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right here. So that's going to be a 1. This is 0, -1. And then this is 4 pi back to 0. plot the points, I got 0, 0. Pi over 4 is up at 1. Pi over 2 is 0, 3/4. So your graph looks something like that. And there we go. Check your work on Desmos if you want. Look at number 2, plot the values and sketch the graph, which we did. How does the graph of y equals sine of 2 theta compare to the graph of y equals sine theta? So y equals sine of 2 theta is horizontally compressed. Y equals sine of theta has a period of 2 pi. And what you notice here is your period length on this graph is pi. Okay? So this one has a period of pi. All right? So what you might notice there is you might remember for your horizontal stretch or compression, you might remember doing this earlier. You have f of x, your horizontally stretched or compressed function is, actually instead of b, let's use a, f of 1 over a of x. So you do the reciprocal. So if you notice there was a 2 there. So y equals sine of 2 theta. Well, what happens is you flip the 2, it becomes 1/2, and it's basically a horizontal compression by one factor of 1/2. That's why I went from 2 pi to pi. All right, you take your period length, 2 pi times it by 1/2, that's where we get the pi. All right, and we saw it on the graph there that it worked. All right, so the third part, predict what the graph of y equals cosine 4 theta will look like and make a sketch. Explain your reasoning. So since I got a 4 there, I think it's going to be a horizontal compression by 1/4. So if my period length is normally 2 pi, you times it by 1/4, your period length is going to be pi over 2. Okay, so I'm going to go to Desmos and I'm going to graph it real quick. So if I graph y equals cosine x, let me change my step to be pi over 2. All right, and then if I graph y equals 4, I'm sorry, cosine 4x, you can see here that the period length is pi over 2. All right, starts, if I'm looking at the blue graph, starts at 0 and ends at pi over 2 right there. Whereas the red graph is your parent function, it goes all the way out to 2 pi. Same amplitude, but definitely compressed. And if you also notice, you could do 1, 2, 3, 4 full periods in the same length that you would normally do 1 full period. All right. So determining your period length of a sine and cosine function. We can kind of figure this out here by saying the length of one period is equal to 2 pi divided by b, or you could say 2 pi times 1 over b. But b is the number right in front of theta or x, and it doesn't matter if it's a sine or a cosine curve. So now we know how to find our period length. So a couple examples here. If you need to jot that down in your notes, might be a good idea to put that on the lesson summary page. because that's not in your book. But like, let me do a couple examples. If my function is y equals cosine of 3 theta, your period is going to be 2 pi divided by 3. All right, 2/3 pi. Or you could just say 2 pi times 1/3, same difference, you get 2 pi over 3. If your function is sine of 6 theta, 2 pi divided by 6, pi over 3. That's your period length. If you have y equals cosine of 1/2 theta, it's going to be 2 pi divided by 1/2, which ends up giving you 4 pi. So that, oops, I know 4 theta, 4 pi. So that one actually gets horizontally stretched because your period length gets longer. Okay. So I'll go back to the calculator here and show you that in action. So, we got cosine of 1/2 x. You see how it gets longer? It's going to be 4 pi. So I look at the blue. There it is. It's all the way 4 pi. It's 1 over 1/2, just like we had. If I put 3x, period length is 2 pi over 3. So right here, 2 pi over 3, full period, right there. Okay. If it's, let's say 4, 2 pi over 4, so that's pi over 2. All right. And it's the same thing with the sine. It's just a different graph to start. Okay, a couple things here, lesson synthesis. So here's a function. This is all kind of review. Midline for this function, y equals -3. Okay, whoops. Midline here comes from that. Amplitude comes from that. And your horizontal translation comes from that. Okay. So how is this graph alike and different from the graph y equals cosine theta? Well, obviously the amplitude is 1 on cosine theta versus 2 on the function above, f of theta. Midline is y equals 0. So amplitude equals 1. Midline y equals 0. It's not translated horizontally. They have the same period length. They both have a period of 2 pi. How do I know? Because there's a 1 in front of there and a 1 in front of there. So 2 pi divided by 1 is still 2 pi. If I wanted to take a look at the graphs, I could to get a little bit more detail. So y equals 2 sine of, what's that? Theta minus pi over 4 minus 3. Okay, right there, and then y equals cosine x. So yeah, obviously that one's also different because the green one doesn't start at a max or a min or at 0. It's kind of like in between there at pi over 4. So a little bit different. All right. Next question. How's the graph of h of theta equals cosine 3 theta alike and different from the graph of g of theta equals cosine 2 theta? So they're alike that they start in the same spot. They're different that they have different period lengths. So we'd say alike, start at 1, because they're both cosine graphs. Midline on all of them is y equals 0. Amplitude is 1. But the period length is 2 pi over 3 for cosine 3 theta. 2 pi over 2, which is pi, for cosine 2 theta, and then 2 pi for just cosine theta. All right, so that's the big difference. The period length will be different. Okay, last thing. Write another function that has the same graph of y equals 2 cosine x minus 1. So I could probably take my sine graph and shift it left pi over 2. So if I keep everything the same, y equals 2 sine of x plus pi over 2 minus 1. Let me take a look at those graphs and see if they are the same. So let's move this down here. So y equals 2 cosine x minus 1. Y equals 2 sine of x minus pi over 2 minus 1. Let's see here. Oh, maybe I didn't. Oh, I put minus and I was supposed to put plus. Sorry. There we go. I knew it was wrong because they didn't match up, but you can look now and see that they are the same graph. All right. All right. Describe how the graphs are alike and how they're different. So alike, amplitude equals 2. Midline equals y equals -1. But different. The first one has a period of 2 pi. The other one has a period of 2 pi over 2, which is pi. Okay. That would be this one is a period of pi, and this one is a period of 2 pi. All right. So hopefully you guys understand how to change the period length on a sine or cosine function.